All right, my math people, we've got a review of transformations. Make sure your name and your period's on your paper. We're not going to do a question for this one because this is review. You've done transformations in Math 1. You've probably done it in Math 8 in middle school, maybe even in Math 7. You've done these transformations. You usually do 4 transformations before you get to this course. Translations, reflections, rotations, and dilations. We're not going to cover dilations today. We're just going to look at translations, reflections, and rotations. So the first one up is a translation. This is just like sliding an image around on your paper. And when we have a translation, we can go up and down or we can go left and right. And we notice that when we translate something, the objects always end up facing the same direction. So let's say that I've got a triangle over here. I'll call this triangle A. And we decide that we want to slide it down to here. If we want to slide it, so we want to go right and then down. And we want to slide that triangle over to there. This would be the image. And we would call this image A prime. So the prime's just a little boop on top there. So you can't really see that. So this is A prime and this is A. So A is the pre-image or the original, and then A prime is the copy or the image. And so what we notice here is when we just do it, it's just like taking your finger and then going, okay, I'm going to move it to here. And we notice that it's always facing the same direction when we do that. So we're going to take the pre-image, and then we're going to move it somewhere, and we're going to get the image over there. And the image is just the copy that we're making. I can't spell today. Copy. All right, so we always start off with some coordinates, so an x, y, and then when we move it, we get x prime, y prime. So the primes just mean this is the copy. So let's say that we wanted to translate something to the left 5 units. So I want to translate 5 units left. So I want to go this way. All right, so if I'm starting off with x comma y, and we're going to the left 5 units, well, left and right affects the x coordinate. So going left is -5. So that would mean your new coordinates would just be x minus 5 comma y. So going left means that you change your x coordinates by -5. If we wanted to translate 2 units right and 4 units down, then the coordinate notation for that would be x comma y. So there's our pre-image, our original. 2 units to the right would be going this direction. So that means we're going to add to our x's. So that'd be x plus 2. And then we'd go down 4. So the y is up and down. So down is -4. So we do y minus 4. So if I started off with something like, I don't know, what if the point was at 1 comma 2? Well, then we just do 1 plus 2, 3. And then for the y, we do 2 minus 4 and get -2. So 1 comma 2, that point would get moved to 3, -2. So just take our finger on 1, 2, and then slide it down to there. All right, so that's a translation. Most people don't need a lot of help with that. Let's get to reflections, which are a little bit harder. So a reflection is like looking into a mirror. And when you look into a mirror, you notice that kind of everything is on the wrong side. So like your right-hand side becomes the left-hand side in the mirror. So when we do a reflection like that, it's not going to be facing the same direction like a translation was, because this is a mirror image where left becomes right and right becomes left. So the points are going to stay equidistant to a line. So let's start by reflecting over the x-axis. So I've already got a triangle here, and I'm going to reflect over the x-axis. So let's reflect. Over the x-axis. All right, so we're going to go over a line and we're going to stay equidistant to a line. That means we're going to stay the same distance. So here's our original. The x-axis is right here. Right? So this is the x-axis. So all of these points are going to stay the same distance to this line. So if I reflect this, this is 4, 1. Right now, 4, 1 is 1 unit away from that line of reflection right there. So I would just put the new point here at 4, negative 1. So 4 stayed the same, but 1 became negative 1. Now over here I've got 1, 2, so now we're 2 units away from the x-axis, so I'm going to go 2 units away down here. And that point, which used to be 1, 2, is now 1, negative 2. Our last point is over at 2, 4. So right now it's 4 units away from there. So now we're going to go 4 units away on the other side. So that's going to become 2, negative 4. All right, let's make our new triangle. All right, so these are the same triangles. They're just a mirror image. You can see that they're kind of both facing towards the line here. Everything's keeping the same distance. But, you know, if we had it this way, we could see that left is becoming right, right's becoming left. It's a mirror image for this one. So what we noticed here is that the x's stayed the same each time. 1 and 1, 2 and 2, 4 and 4. But the y's changed their sign. 2 became negative 2. 1 became negative 1. 4 became negative 4. So when we reflect over the x-axis, x stays the same, y changes its sign. So if I did coordinate notation for this one, the x and the y, we would just get x staying the same for the image, but the y would change its sign. So we just call that negative y. All right, now let's reflect over the y-axis. All right, so now the y-axis is right here. So there's my y-axis. I'm going to stay the same distance because that's what you do in a reflection. You stay the same distance. So this point is at 1, 2. So I am 1 away from the line of reflection. So I'm going to go on the other side 1 away. So there's my new point. And that point is at negative 1, 2. All right, this point is at 4, 1. So it's 4 units away from that line. So I'm going to go 4 units away on the other side of the line. So that would be the point negative 4, 1. And then over here, this is 2 units away. So I'm going to go 2 units away on the other side. All right, and there's our reflection. Now what we notice here is the x's now have changed the sign, but the y's have stayed the same. So 4 is still 4, 2 is still 2, 1 is still 1. But the x's have changed their sign. This was positive 2, now it's negative 2. This was positive 1, now it's negative 1. This is positive 4, so it's negative 4. So the y's are staying the same this time, but the x's are the ones that's changing. So the coordinate notation would be x, comma, y. And then the x would change, but the y stays the same. So when you go over the x-axis stays the same. When you go over the y-axis, the y stays the same. Now you can reflect over other lines. Let's say real fast that you wanted to reflect over the line. This would be the line y equals 2. So let's say that I've got a point here and a point here, and I'm just going to reflect a line this time, a segment. So now we would go 1, 2 to get up here, so I'd have to go 1, 2 to get up here. So we would just pretend like this line right here was the x-axis in this case. So I'm still 2 away from that line. And then this one is 1, 2, 3 away, so I'd go 1, 2, 3 away up here, and our other line would be here. So we could still do it over lines that aren't an axis. So if they go side to side, if they're horizontal lines, it's going to be y equals 2. If we want to do a vertical line like this, that would be the vertical line x equals -2. So vertical lines are x equals something, horizontal lines are y equals something. All right, let's do rotations, our last one. All right, rotations. This is when we spin around a point. So we're going to pick a point, and it's like picking a point and then starting to spin your paper around that point. In fact, this is one of the ways that you can actually do a rotation, is to spin your paper to see where it's going to end up. So usually, just to keep it simple, we're going to spin 90 degrees on these ones. So if I wanted to spin 90 degrees counterclockwise or 90 degrees counterclockwise, or it's the same thing as 270 degrees counterclockwise. Because remember, 360 is going in a full circle. So 90 degrees would be like spinning your paper once this direction counterclockwise. 270, that's 3 90s. So if you spin it 3 times, 2, 3, if you spin your paper 3 times, it's the same thing as spinning it once in the other direction. All right, so 90 degrees or 270 degrees. So basically, anything in this quadrant in 90 degrees is going to spin, and we're usually going to spin around the origin, is going to spin 1 quadrant over for each 90 degrees. So since we're going 90 degrees counterclockwise, so we're going in this direction here, 90 degrees, anything in this quadrant here will move to this quadrant. We'll move over into this quadrant over here. If we did 180 degrees, it would move 2 quadrants. So it would go 1, 2 quadrants to get to here. And then 270, we go 1, 2, 3 quadrants to get there. So what we have here is spinning it, and we're always going to stay the same distance from this point. Now, on a reflection, we stayed a distance from a line. Now we're staying a distance to a point. It's like we have a rope attached to the origin, and we're just spinning using that rope. Okay, so if I start spinning this one 90, this point here is only going to make it to here. It's going to still stay a distance of 1 away from the origin. So this point here is going to end up being 0, 1. Now look what happened. The x moved to the y place and the y moved to the x place. There's something a little bit more than happening than that, but let's see. So our notation is x comma y becomes negative y comma x. So basically when we turn it, whatever is in the x is going to turn into the y position, and anything in the y position is going to change its sign and go into the x position. So let's look at this one. So right now I've got 2, 3. So I'm going to switch those 2 numbers. It's going to be 3, 2. But when I move this 3 over here, it's going to turn negative. So I'm going to go 1, 2, 3, negative 3, positive 1, 2. About right there. All right, so that one ends up being negative 3 comma 2. Now look what happened to these 2 numbers. The 2 moved to the y. The 3 moved to the x but changed its sign. All right, now let's look at 4, 1. We're going to switch these two numbers. It's going to become negative 1, 4. So negative 1 and then up 1, 2, 3, 4. Right there. So look what happened to the numbers. 1 goes to negative 1, 4 goes over to here. So they switch the order. Now we can actually prove that this is what's happening by spinning our paper. And you've already done this in another class. Hopefully this is kind of starting to jot your memory. But look at this. We can see that this point is still the same distance away from the origin. This point over here is still the same distance away from the origin. And this point here is still the same distance from the origin. We just kept the distance, but we spun it. Now watch what happens when I spin my paper. Now keep an eye on this point right here, 1, 0. I'm going to spin my paper 90 degrees. So there, I spun my paper 90 degrees. Now look where it's at. That's at 0, 1, right? And look, 0, 1, that's where that's supposed to be. Watch this one right now. I'm at 4, 1. Keep your eye on that point right there. We're at 4, 1. Spin our paper 90 degrees counterclockwise. Now where's that point? That point's at negative 1, positive 4. Right? Back 1, up 4. And that's what we have there. Negative 1, positive 4. Lastly, let's look at this point right here. Keep your eye on it. Keep your eye on it. Stay on target. So we're going to spin it. There we go. And look where that point is now. It's at 1, 2, 3, and up 1, 2. So spinning it 90 degrees, negative 3, 2. And you can keep on doing that trick if you don't memorize like the really rules for how these are moving. You can always use that spin your paper trick. 180 degrees. What we notice about, and this is counterclockwise or clockwise. Oh, this was supposed to be clockwise. So this one doesn't matter. So when we do this one would be negative x, negative y. Because look, if you do this one another 90, this would move here and change its sign, and this would move to right there. And then 270 degrees counterclockwise, or 90 degrees clockwise. That one would be at y negative x. And it makes sense because look, the x moves to the y spot, the y moves to the x spot but changes its sign. So y negative x. All right, so all this stuff that we've been talking about, the translations, the reflections, and the rotations, we call these rigid motions. And this is why it's really important for the unit that we're in. Because rigid motions are a type of transformation where the angles and the side lengths are staying the same. So we know that rigid motions create congruent shapes. So instead of doing a proof, if we had something on a graph paper, if we could prove that there's some kind of rigid motion happening here, like a translation, a rotation, or a reflection, we don't have to do all that side angle side stuff. We can just show that it is one of those rigid motions, and rigid motions create congruent shapes. And so we can prove the triangles are congruent just by transformation, by showing it's a rotation, a reflection, or a translation. All right, that's all I got. We will actually do more with transformations in the next lesson, but you're going to have to wait till next week for that one. All right, be good. See you later. It's time for me to go home. Bye.